Very good morning, everyone. I'm Preeti Sharma. I'm a research scholar in School of Computer Science, UPES, Dehradun. I'm working under supervision of Dr. Hitesh Kumar Sharma as Senior Associate Professor in UPES, Dehradun, India. He is my internal supervisor, and Dr. Manoj Kumar, Associate Professor Engineering and Information Sciences, University of Wollongong, Dubai, UAE. He is my external supervisor. Today, in front of you, I am going to present my research on the topic Unsupervised Multiscale Image Enhancement using Generative Deep Learning Approach. I am thankful to the 12th International Conference on Soft Computing, Artificial Intelligence and Application SCAI 2023 to give me an opportunity to present my work on this platform. Moving forward, we have content to be discussed in today's presentation are abstract, introduction, literature review, our objectives of research, methodology, results and discussion, comparative analysis, conclusion, and finally the references. Moving with the abstract part, as we all know that today's the demand of the world is to have super resolution images which are free from the noise. So producing super resolution images is really essential, and it can only be achieved if we eliminate the noise element and give a noise-free output. To achieve this purpose, we have used a multi-scale image representation of the images that we find is very effective in many ways because of its accuracy of correct feature extraction capacity. It works as an denoising approach and is integrated as an enhancement tool in the form of ensemble GAN model. So basically, we employ an ensemble GAN approach as a denoising element to produce super resolution images. In this research, we have make a multi-scale image representation approach using ensemble GAN, as I said, with hybrid discriminator architecture. Also, the great thing about this model is that it works equally with all type of noise. Means it has the capability to remove the noise element from the images. This technique optimizes training through simultaneous generator and discriminator model training, and by their adversarial training approach they are capable to improve each other, and finally generator comes in the condition to produce good quality images which are noise free. To evaluate the performance of our model, we have used the accuracy, IS, that is the inspection score, and the FID, that is the French's inspection distance, as the evaluation metrics. And we have observed that our model is performing very well with an accuracy score it attains, that is 99.91%. Moving with the introduction part, I want to tell you that in today's world, deep learning is producing remarkable results in different application areas. From the deep learning field, we have one of a great element that is generative adversarial network. GAN in today's world is playing a very important role to generate real-like images. We are utilizing this feature of GAN to produce noise-free outputs to finally get super resolution images. As we know that GAN is made up of two components. The very first module is generator and the second one is discriminator. Generator uses noise and try to create an image. Initially, it sent that image to the discriminator. Discriminator try to classify it whether it's a real or a fake image. The more capable discriminator is, the more generator try to create more good image which are real-like images, so that discriminator would not be succeed to classify the images properly as real and fake. This process somewhere helps in the adversarial training of both the networks. That become one of our great tool for utilizing GAN as a multi-scale denoiser element. So our research is totally focused on using GAN as an element which is capable to remove the noise up to an extent that is helpful to create a good quality image. For making a generalized solution for creating the good number of images with high resolution, so we call it super resolution, we use a ensemble technique in the discriminator part. What we are doing here, we are putting up 3 discriminators which are working in a parallel fashion. The generator initially generates an output and send it to the 3 discriminator. The 3 discriminator are working on the multi-scale approach, and they are taking the features, different features, and execute the image, generated image by generator, to classify or to identify whether it's the real or the fake. This process goes on up to 50 iterations initially. The best discriminator which find out the image with minimum loss is finally selected after the 50 iteration to go or to couple with the generator in rest of the iterations. So the total concept is based on multi-scale approach utilized by the 3 discriminators, as well as the minimum loss function that is being generated or that is being calculated by the discriminator. After 50 iteration, the discriminator with minimum loss is finally being selected to couple with the generator to execute the GAN process to create good quality images. Also, we can say that this 3 discriminator approach works like a pyramid feature construction, where each discriminator utilize the feature, whether it's depend on the discriminator on the spot. It's like working in a dynamic environment. Discriminator itself select the type of feature for which it finds itself to show the minimum loss. Moving forward in this direction, I want to discuss with you about the pyramid features, as I mentioned, to create the features pyramid that can leverage further through convolutional and downsampling process, that is about the visual background data is converted across local to global perspectives, and utilize its adversarial training that GAN might as helpful or assistance overall image restoration to yield super resolution or high resolution images. So we can say that our research basically work out to improve 3 major constraints listed in the image enhancement environment. The very first is enhanced image contrast and lighting that may sometimes result in color distortion and inconsistencies, and sometimes the bright area of dark images may be overexposed. GAN is successfully able to create a picture which is homogeneous with the contrast value throughout the image. Second constraint which it is able to solve is due to unstable training of unsupervised models, contiguous regions may perform sharp color or illumination discriminancies. But due to the adversarial training approach utilized by the GAN, this particular problem has been resolved up to a great extent. The third one is model with a single frame-to-frame mapping network when applied to low light, high noise images are primarily concerned with illumination enhancement. The quality and the best feature of GAN, that is to create real-life pictures, help to resolve this particular constraint to create good quality images. So in this way, the ensemble GAN approach, I find out or I observe, they work well to resolve the three important concerns in the image processing and creating the good quality images. Now, these are few of the related studies which are bring up with the very good results and good research which may bring up with a good foundation for the future researchers. The very first I have with Yan et al. He configured his self-consistent GAN, that is SC GAN, which allow unchecked noise and can dynamically extract noise map from the noisy images. And then it model them and create new self-consistent images that complement each other. A very clear input should result in a zero response from a noise standard. Once presented with a pure noise input, a noise model ought to produce the same result. The major image processing task, it include about blind image denoising, streak removal, noise image super resolution are achieved through SC-GAN. The second milestone in this research journey about GAN is Lee et al. That has suggested a deep convolutional CNN model, that is about a convolutional neural network that is built on the deep learning approach and it consists of several units. This ensemble model helped to employ a comprehensive 3D convolutional method, and its potential helps learning beyond pre and post processing to such ensemble architecture to produce good quality images. Finally, we have two more, that is Lee et al. That guaranteed a revolutionary generative adversarial network that is based on deep attention mechanism and multi-scale feature transmission blending. And Wang et al. That fulfilled the image denoising goal with a deep residual network based on GAN network. Moving with our objectives, the very first objective we have designed is to design a GAN model that is generative deep learning approach as a multi-scale image enhancement model. For implementing this multi-scale image enhancement, we have utilized three discriminator architecture that are based on minimum loss calculation on which the whole GAN will work out. Then the second approach is to devise the efficient ensemble technique, which I mentioned is based on 3 discriminators. I search it out for the 2 and for the 4, but I find out the most optimum values we got at the 3 discriminator architecture. When we are having 2, the image quality was suffering, and when we have 4, we have come up with the training issues. For discriminators, we have come up with the training issues like mod collapse and convergence of GAN. And final objective is GAN ensemble that efficiently balance the computational efficiency and learning effectiveness, making it a practical solution for real-time applications. Now the methodology part. In our methodology part, the very first thing that how should we develop the model. For development of the model, as I mentioned, we have taken up least loss function to get finalized the discriminator to work with the generator. The initial iterations are required for implementing the multiscale features to be utilized by the generator to create good quality images for rest of the iterations. So basically, the model deployment or the model development based on a single generator, that is also a CNN model, and another 3 discriminator ensemble model that are deconvolutional model, you can say. And by the adversarial training based on the least calculation function or least calculation loss values the discriminator produce, the generator improve itself, and by this adversarial training approach, the generator is finally able to improve itself up to a level to create good results in terms of image enhancement as super quality images or high definition images. As I mentioned you about the loss function, we have equation that is about G of min and D of max, means the generator have to show with minimum value of a function that is about 1 minus dx, and the d max should be maximum with the value that is about ez minus pz dz of z, where z is the noise. This is the mathematical equation that is used for calculation the values of GAN employed. Now, the second part is selection of the generator and discriminator networks. So as I told you, for implementing the generator, we have worked with the convolutional network of 7 layers, and for discriminator part, deconvolutional network that is again of same configuration. The method I already been discussed. So this is about the architecture we are having for our model. Here you can easily say that through back propagation, the value of the loss come up with the discriminator, the minimum value that's back propagate to the generator, and basis of that generator improve itself, produce new image, then give it to the as input to the discriminator again try to classify it whether real or fake, and as soon as discriminator is able to classify, it means more efforts are required by the generator to train itself in a better manner to produce good quality of images. And the point when the discriminator loss become high, it means the discriminator loss become less, it means that the discriminator is not able to classify the things, the images as real and fake. It means it getting confused now. It means the generator get trained itself up to a level that it comes into the position of creating super resolution images. This is about the layer architecture. We have input layer initially. This is about the broader area, about broader discussion about the layers we have employed. We have an input layer that is about the raw image data that is derived into the network. Then we have one convocational layer which has a total of 16 filters utilized. Then we have a pooling layer that works that's been added after each convocational layer to minimize the spatial dimensions. Then again a convocational layer with 12 filters, then pooling layer, then convocational layer with 10 filters, and so on. Finally, we have some fully connected layer with one neuron to the remaining, so that the remaining feature maps are flattened and processed through fully connected layer. And we have finally the output layer to produce the result, and the sigmoid function is being used as an activation function in the output layer. This is about the training and the algorithm. As you can see, the algorithm is written in the pseudocodes that first of all we give data samples and some noise samples of face images. There is pre-training of the GAN generator by fixing the reconstruction parameters. Then GAN fake denoise generation through adversarial training with ensemble discrimination feedbacks. Then we have deep learning ensemble detector applied to verify the GAN generator as GN1 plus GN2, means it is the sum of the results produced from step first and second. Then it optimize and update each of the discriminator in the ensemble model. Then it minimize the generator loss function and updates and the fake and the real image classification analysis output we get for the discriminator, and which help for the further adversarial training of the generator. This is about the training, and as I told you that we have upscaled images for super resolution, as we all know. So we feed in the downscaled photos and let the generator network create them, and we use noisy pictures for denoising and Gaussian kernel blurred images for deconvolution, and then we have batch normalization for maintaining the stability in the model. And both generative and discriminative network help due to the batch normalization to avoid gradients from contracting or expanding. Now the data set we have used, that is about from the Google facial expression data set. That is a wonderful data set that consists of 87,517 verified photos, and these are images. Our pre-processing tools are being applied, and for faster computation of loss function and identify suitable normalizations. And on the sample data, the training and the test samples are divided in the ratio 7:3, means for training we have utilized 70%, and for testing we have count for 30%. Now for evaluation of the work, as I mentioned, we have used accuracy, inspection score, and FID for finally calculate the model performance. We have the experimentation and result here. As you can see, we have make 5,000 iteration for getting the final outputs, and as you can see, initially for 50 epochs it has noise everywhere. Then by 500 some faces start creating. Then by 1000 we are in position to identify few like eyes. We have somewhere we have nose. We are able to identify the different features on the faces. And finally by 5000 we have very good results that are created by the GAN model, that are look like the real images. So our purpose are solved as we find out with this ensemble technique. Moving forward, we have other results which show the good performance of the model. As you can see that the D refers the discriminator, real and discriminator fake, means it's defined the efficiency of the discriminator about its classification efficiency, and the green respond to the generator working or performance about the data set. Then in figure 7 we have the multi-scale ensemble GAN model loss functions, and as you can easily see that the loss values are for discriminator and generator, and for generator these are getting increased, and for discriminator they are getting decreased. This is about the IS and the FID curve. That is, we have find out that 1.4 value for the IS and 44.12 for the FID model, that is 41.2 actually. Then we have comparative study with the existing approaches. It is about 99.91 in our case, 99.5% for the model developed by Wang et al, and 98.90 and 69.51 for MIST and CIFER 10 dataset performed by Benny et al. So finally, we have conclusion in our hand. I must say that the presented research provide a very short technique for denoising and super resolution by the combination of the multi-scale image representation with an ensemble generative adversarial network using a hybrid discriminator architecture designed for multi-scale analysis. The model exhibited a really surprising capacity to manage various types of noise inherent in the input data. The training approach, which includes simultaneous update or the adversarial training, we can say, to the generator and the discriminator model, optimize their learning technique, and they are capable to dynamically choose the discriminator with the lowest loss function that improves overall accuracy and the output and the quality of the picture. IS optimum values achieved by the IS and FID highlights the good performance of the proposed GAN model with a great accuracy achieved, that is about 99.91%. So this study enhanced the state of the art in denoising technique and also demonstrate the versatility of ensemble GAN for dealing with diverse form of noise in multi-scale image representation that results in high quality noise-free image. In terms of future work, there are several restrictions toward the suggested GAN model despite its ability to provide realistic synthetic discrete data. Even the time series data also required to be addressed, and it has been difficult to analyze, to figure out how to make it for useful for current application, especially for the medical research, which really required high quality images, high definition images. So this is about my work, research work. These are the references. Thank you very much.